Okay, good afternoon. Welcome to Math for Kids number 15. Sorry the board looks so funny. We did a little bit of erasing and cleaning, and now we've got a little bit cleaner board. So here we go. Math for Kids number 15. The average age of 5 kids at a math club is 10. The 16-year-old shows up later. What is the average age of the 6 kids now?
So we're doing the average, math average.
Math average, yeah.
So we add up the numbers and then divide by the number of numbers.
Okay, so do you understand the problem?
Yep.
Okay, what do you have to do on a problem like this? How do you solve it? This one's not super easy. What are you supposed to do?
We're gonna understand the problem.
Okay, great. Let's understand the problem. What's the first thing you have to understand?
That there are 5 kids at the math club.
Okay, what do you know about those 5 kids?
The average of 5 kids in the math club is 10.
What did I write?
The average age.
The average age. Okay, so we have 5 kids and we know the average age of these 5 kids is 10.
So
what does that mean?
let's first figure out what are the ages of the 5 kids.
Okay, let's see if we can do that. So the average age of 5 kids at a math club is 10. We've got to figure out what that means.
Well, it doesn't say anything about consecutive or anything.
No, it doesn't. It only says their average age is 10. Okay, so let's see if we can figure out what that means. Okay, what does it mean that their average age is 10?
Well, it means all the kids' ages added, summed up, and then divided by the number by 5
Is equal to what?
is equal to 10.
Okay, so why don't you write that down? So, sum of ages.
Ages. I'm just going to sum of age.
Sum of age.
Well, sum of age has to equal 50.
Okay. Why?
Because 50 divided by 5 is 10.
Okay, so write that. Sum of age equals 50. And we know that. Let me just say why we know that. We know because the average, if the average equals 5, if the average age equals 10, it means the sum of ages divided by 5 equals 10. And so that means the sum of the ages is 50. So for the sum of the age of the 5 kids is 50. Now what happens next? Do you remember?
And then a 16-year-old shows up.
Okay, and then a 16-year-old shows up. So what's the sum of the ages now?
So 50 plus 16.
Yeah, what is
60. 50 plus 16, that's 66.
Okay, so how many kids are there now?
There's 6 kids, so we do 66 divided by 6, which is going to equal 11.
Okay. So when the 6th kid shows up, that 6th kid is 16 years old. So now we know the total sum of the ages is 50 plus 16, which is 66. So we know the sum of the ages equals 66, and the sum of the ages divided by 6 is the average. I like to write av for average.
And then 66 divided by 6, that means...
66 divided by 6 is equal to what?
Well, the av equals 11.
Okay, 66 divided by 6 is 11. Okay, great. Good job. Can you erase this for me and we'll do the next problem?
Okay.
Here we go. Okay, here's the next problem. Using only dimes, quarters, and pennies, make 77 cents using the most number of coins. That's the first problem. Actually, I didn't write this problem very well. Okay, that's the first problem. Using the most number of coins, and then the second problem we'll do second is what is the largest number of coins if you have to use at least one of each coin. So if you have to use, the second problem says you have to use at least 1 dime, 1 quarter, and 1 penny. But the first problem is using dimes, quarters, and pennies make 77 cents using the most number of coins. But there's no restriction on how much of each you have to use.
I think I know the most number.
What?
It's 77 pennies.
Oh, very good. Wow, you saw that one really quick. I was trying to trick you. Okay. So the largest way to, using the most number of coins, the largest way to make 77 cents is to use 77 pennies. And why does that give you the highest number?
Because, I'm just going to write most number equals 77 p's.
77 p's, okay. Why does that give you the most?
It gives me the most because pennies are worth the less.
The least.
So yeah, the least.
Worth the least, okay. It was like yesterday when we were talking about making fractions.
Yeah,
big.
we gotta make.
You have to make the bottom small. So if you're going to try to use the most number of coins, you try to use the smallest coin. Okay, but what's the most if you have to use at least one of each? Okay.
The most is most number. So we gotta
Now what if you have to use one of each, at least one of each?
So we can use 1 quarter and one nickel and one dime. Well, that's 35 cents.
Okay.
And then
Probably a good idea to write something down here.
so I'm gonna use 1 quarter. I'm calling the quarters Q,
Okay.
the dimes D, and the pennies P.
Okay.
So 1 quarter plus 1 dime, and that's gonna equal 35 cents.
Okay.
So 35 cents, and we gotta make 77 cents.
Yeah. 35 cents, and now we got to make 77 cents.
30 and 40 is 70, and then we can use 42 more pennies.
Okay.
So we use 1 quarter plus 1 dime plus 42 pennies.
Okay. So how many coins did you use?
So 1, 2. I used 44 coins.
44 coins. Very good.
Those weren't too hard.
Yeah, those are fun little problems though. The two problems I made are a little tiny bit different than the homework problems, but that's okay. Okay, you ready for the homework problems?
Yep.
What are you doing? Making happy swirly-eyed guy?
Happy hypno dude.
Okay, so hold on a second. So it's Olympiad 6, problem number 3, and problem number 4. Let me bring the camera back up here.
Make the camera up.
Olympiad 6, problem number 3, problem number 4. Homework. Oh, give me your marker. Olympiad 6. Really? Are we on Olympiad 6 already?
Olympiad 6?
Oh, I guess we are. Olympiad 6, problem number 3, problem number 4. Alright, that's the homework. Good job, sweetie. Yeah, you did a great job.